Hello, welcome back, and in this video I'm going to show you how to make your first schematic, simulation, and printed circuit board in the Capture CIS Lite and PCB Editor software suite. So let's go to the Start menu here and choose All Programs. Next you want to scroll down to the Cadence Release 17.2 folder. So I'm going to go in OrCAD Lite here, and you should have Capture CIS Lite. So click on that. This is a software tool that's going to help you create your schematic or your drawing for your LED. So go to File, New, Project, then name it LED. Make sure it's a Pspice analog or mixed AD option for your project here. That allows it to be simulated. Now under the location, click the Browse button here. I'm just going to put this project in the Documents folder. So click New Folder. I'm going to name it LED. Go into the folder here, select it, then click OK. I'm going to create a blank project, so make sure I create a blank project here and click OK again. Then Capture CIS will load a new schematic page for you to put your circuit onto. Now there's a lot going on here, but there's a lot of things that you don't really need to know, and just a few things that you do need to know to get your schematic made. First, it's the part place option. So go over here to Quick Access toolbar and choose Place Part, or hit P on your keyboard for short. That will open up the Place Part window, and you want to type in R for resistor. Now this shows up here for me because I already have this library added, but in case you don't have that library, if it's your first time using the software, look under Libraries here and then choose the Add Library option. Now R is in the analog folder, and that would be this right here. This is a library, and I'll explain this later on in the course, but these are libraries that house the parts that you need. So choose analog.olb, and when you type R in the part search field, it shows up. Hit enter on your keyboard so it gets attached to your cursor. Alright, now I want to rotate this part, so right click, choose rotate, and then it rotates it there, and just click once to place it onto the schematic. Next you want to add a VDC. It doesn't show up, and that's because I don't have the library selected that would house the VDC. And in case you don't have the library either, just click on Add Library, and then that would be under Sources. So let's just look for the source library, source.olb, click Open, and VDC appears. So this is a DC voltage source, so just hit enter on your keyboard. Click once to place it on the schematic, right click, and then choose End Mode, or you can hit Escape on the keyboard. Next I want to add an LED. So I want to just select all of these libraries that I do have. In case you don't have these, click on the Add Libraries button, click once on any one of these libraries, and hit Control A on your keyboard, and then choose Open. What this does, it adds all those libraries in that folder into this libraries section here. Sometimes they're not all selected, so just click once on one of them, then hit Control A on your keyboard to select all the libraries. Okay, let's look for LED. Now LED shows up under the discrete library option, but I'm not sure if I can actually simulate this LED. And also, sometimes the LED option won't even appear if you don't have certain libraries available to you. So I'm going to show you how to look for a part that you don't know the part number for or don't quite know the name of. Go to Place, Pspice Component, Search. Now the Pspice part search window appears, and I want to look for an LED under the optoelectronics device. Expand this folder, also expand LEDs. I'm going to go with a 5mm T1 0.75 package. Choose Amber. I click once on this first option, then double click for it to attach to my cursor. Why am I going through all this? It's because I know for sure that when I use the Place Pspice component option, that the device can be simulated. With these other libraries, they may not necessarily be simulatable, which is not a real word, but you get the idea. You may not be able to simulate those parts. So this is the method I like to go with. Alright, so hit R on your keyboard to rotate it. Place it right under the resistor there. Right click and choose End Mode. I'm going to close this window and then add one more thing, which is a ground component here. So you can either hit G on your keyboard or click Place Ground on the Quick Access toolbar. And go with 0 CapSim or 0 Source. Either one is fine. And click OK. Place it right under the LED, and right click and choose End Mode. Now it's time to wire the components. So click Place Wire and then click Release to make your vertices and your connections. Alright, so just be very careful when you're connecting these components. Okay. Oh, so I made a mistake here. Just end wire. And whenever you make a mistake, you can just click drag and hit delete on your keyboard, and that'll delete the extra wire. So go to File and save your project. Now I'm going to change the values. So for the resistor, double click on the 1K, change it to 500, hit enter. And for the V1 device, or this DC voltage source, change that to 9 volts DC and click OK. Now I'm going to simulate this circuit. Add a voltage marker between the resistor and the diode here. So I'm going to place this V voltage marker right in between those components. Just wait for it to load. Okay, right click and choose End Mode. Now, in case you don't have this toolbar, you can just go to Pspice markers voltage level, and then this is where you can find the markers that you want. You can take a differential voltage between circuit components or a voltage from that point to ground. So there's a lot of options here for markers. So what this voltage probe is going to show us is the voltage between these two components with respect to ground. And it will always do that. Wherever point you're placing it onto, it'll take the potential from that point to ground. Okay, so now let's set up a Pspice simulation profile. Go to Pspice, new simulation profile, and then type in something like DC transient, because we're going to show the progression of the voltage over time. Click Create. Then click on this little window that pops up here, and this is the simulation settings in Pspice. For the analysis type, choose Time Domain. Set the runtime to 1 second. Set the maximum step size to 0.1. Click Apply, then OK. Now the probe disappeared. That's interesting. Okay, so you want to make your probe markers. You want to place them onto the circuit after you've created your simulation profile. So let's place a probe again. Pspice, markers, voltage level, right there. Okay, right click, choose End Mode. Now you're ready to simulate. We'll go to Pspice again, then click the Run button. And now this window shows up on the bottom. This is the Pspice simulator window. Okay, the voltage remains the same over the course of 1 second, and it's just under 2 volts. Now, where is that voltage? Like I mentioned earlier, it's the voltage between this point and ground. So there's a huge voltage drop here of 7 volts from this 9 volt VDC device here. Okay, it's a pretty big drop, but that's fine. Now that you've simulated the circuit, I'm going to show you in the next video how to create the PCB from your LED schematic. See you in the next video.